Hello everyone, and thanks to be here today. We want also say thanks to NI to give us the opportunity to present today. I'm Samuel Guéné, the CEO and founder of Gemesis, and I will be assisted by Andy today to present some things about the fuel cell and the platform approach regarding the development of this technology. So Andy, maybe you can start to present the company and to present the subject. I will finish it regarding the technology we developed.
Okay, wonderful. Thank you, Samuel. Let's get stuck in. Okay, so hello everyone. Thank you for being here. We're delighted to welcome you here to discuss the potential of a platform-based approach for validating an energy storage system using hydrogen, from membranes to complete fuel cell systems. First of all, we'd like to thank our technological and strategic partner, NI, for giving us this opportunity to present today. We'll be focusing on the challenges that engineers face when developing complex systems, and we'll address a topic we know well, hydrogen and fuel cells. But before diving into the details, allow us to take a step back and introduce Gemesis. So Gemesis is a partner company of National Instruments, specializing in the design of testing systems for laboratory and production environments. We focus on advanced technologies such as hydrogen-based systems, vehicle electrification, additive manufacturing, aerospace electrification, biotechnology, and microfluidics. To achieve this, we offer turnkey systems, services, and software tools. We can design and manufacture testing solutions in our own workshop. And additionally, we follow an open source approach, which we'll present to you in more detail a little bit later. So we aim to develop an approach that includes a testing center currently in the final stages of funding in France, dedicated to hydrogen and battery technologies. This center will feature measurement capabilities to understand the internal phenomena of components. It will be complemented by a test bench production center to support advanced validation and production teams with the same tools and a team of experts specialized in industrialization. To face this challenge, engineers are confronted with complex issues. They must develop increasingly sophisticated technologies to optimize system performance and energy efficiency while reducing costs and operational expenses. They also need to be mindful of materials, especially rare ones, and integrate new energy sources while addressing stricter environmental regulations. All of this must be achieved while reducing time to market due to financial pressures, climate concerns, and the growing demand for technical iterations. At Gemesis, we are convinced, and NI shares this belief, that the best way to address these challenges is through a platform-based approach. This approach provides significant advantages. Reduced development costs, it creates links between teams and business units, it capitalizes on learning and lessons learned, breaks down silos, decreases time to market, and enhances security. In the development of hydrogen technology, the challenges in terms of safety, complexity, and cross-functional integrations are immense. Therefore, it's preferable to avoid spreading resources across a multitude of tools and issues, allowing us to stay focused on a unified and effective approach. Hydrogen's a unique and versatile element with many potential applications. Despite being the most abundant element in the universe, it's not commonly found in its pure form on Earth. Instead, hydrogen must be extracted from other sources, such as water or hydrocarbons. One of the most promising applications for hydrogen is as a fuel source for vehicles, where it can be used to power fuel cells that generate electricity without producing harmful emissions. Despite its challenges, hydrogen has many advantages as a fuel source. It's been used for over 60 years in various industrial sectors. In addition, hydrogen has a high energy density by mass, making it ideal for use in transport applications such as cars and buses. And finally, hydrogen can be produced from renewable sources such as solar and wind power, making it an attractive option for reducing greenhouse gas emissions and combating climate change. While hydrogen has many advantages as a fuel source, it also has some significant challenges. Hydrogen is difficult to detect as it's both colorless and odorless and has an invisible flame. It also requires special handling precautions due to its high flammability in the presence of oxygen. Additionally, hydrogen has a low volumetric density, meaning that it must be stored at high pressure or very low temperatures in order to be efficient. And finally, certain materials can deteriorate in contact with hydrogen, necessitating the use of compatible materials in order to ensure safety and reliability. Fuel cells are a clean and efficient way to generate electrical energy. They operate on hydrogen and oxygen, with water and electricity being the only byproducts. Fuel cells can be used in a variety of applications and have the potential to revolutionize the way we generate and use energy. As our world as our world moves towards a more sustainable future, fuel cells will play an increasingly important role in achieving our energy goals. So, to understand how a fuel cell works, let's take a closer look at the chemical process happening inside. In a fuel cell, hydrogen and oxygen combine to produce electricity, heat, and water, with zero harmful emissions. Unlike batteries, fuel cells continue to generate power as long as they're supplied with fuel, hydrogen in this case. The process starts at the anode, where the hydrogen molecules are split into protons and electrons. The protons pass through an electrolyte, while the electrons are forced through an external circuit, creating an electric current that we can use as energy. At the cathode, the protons and electrons reunite with oxygen from the air, forming water as the only byproduct, along with some heat. This technology is highly efficient, quiet, and produces no emissions, making it an ideal solution for applications in mobility and energy storage. By harnessing hydrogen fuel cells, we can power a wide range of systems sustainably. In a fuel cell, the core reaction happens at the membrane. This is where the hydrogen ions pass through to combine with oxygen, creating electricity, water, and heat. But achieving high performance requires more than just a membrane. The entire system, known as the balance of plants, involves essential technologies like valves, humidifiers, and DC to DC converters, which support and control the reaction. These components are crucial for maintaining stable operation and efficiency. For market applications, it's essential that the entire system is both carefully designed and optimized, ensuring reliability and performance tailored to specific needs. Companies developing fuel cells or electrolyzers face the dual challenge of working on the balance of plants, integration, as well as the core technology of the fuel cell itself. This is a complex undertaking, especially considering the intricacies involved in studying a fuel cell stack. A stack is essentially an assembly of bipolar plates and membranes, where specific input parameters can have a substantial impact on defining the system's overall performance characteristics. Key performance characteristics include power density and the total power output of the stack. For individual cells, which consist of bipolar plates and membranes, electrode assemblies, or MEAs, crucial parameters include cell voltage, nominal pressure, and the ratio of active surface area to total surface area. Additionally, factors such as thermal management and precise control over stoichiometry and reactant flows are essential for optimizing efficiency and durability. By addressing these parameters, companies can develop fuel cell systems that are not only efficient and powerful, but also optimized for specific market applications, whether in mobility, stationary power generation, or other industries. The core of the fuel cell is the MEA, or membrane electrode assembly. This is where the reaction occurs. Positioned between the bipolar plates and the membrane, this is where the science of electrochemistry takes shape and requires thorough study. Developing numerous specialized test benches is essential to create a competitive fuel cell. The membrane itself requires different test benches supplied with hydrogen and air. These benches must be able to regulate the pressure and humidity levels of each gas. Additionally, electrical load control is necessary to manage current consumption and accurately characterize the fuel cell's performance. In many cases, it's essential to perform impedance spectrometry, spectroscopy, measurements to understand the electromechanical mechanisms within the membrane. These measurements can sweep across a frequency range from several tens of kilohertz up to megahertz for the most advanced analysis. The control laws applied in these tests have a significant impact on the results obtained. Synchronized measurements are essential to fully understand the electrochemical phenomena and achieve accurate results. As demand for energy storage grows, these large-scale factories face significant challenges. They need to speed up production, standardize testing processes, and efficiently manage data collection. To tackle these challenges, adopting a platform-based approach becomes essential. Such a platform not only saves time, but also ensures consistency in testing and simplifies data retrieval across multiple systems. At Gemesis, in partnership with NI, our approach is to provide the tools necessary for building a flexible automated testing platform that can be tailored by the client to meet their unique needs. NI supplies the core technology and tools required to design this type of platform, enabling robust data integration and system control. Meanwhile, Gemesis offers both specialized tools for specific industry needs and custom test benches when required. In the upcoming slides, we'll walk you through our approach and demonstrate how our combined expertise helps gigafactories operate more efficiently and effectively. To build such a standardized platform and toolset, Gemesis leverages the comprehensive suite of NI solutions. And on the software side, we've got LabVIEW, which serves as the foundational language and platform, providing a robust and versatile environment for development. For clients needing flexibility, we also offer integrations options for Python and C#. We utilize NI Veristand for complex HIL, as hardware in the loop solutions, and TestStand for managing intricate test sequences. NI System Link enables efficient data retrieval, data management, and standardization of post-processing. On the hardware side, we rely primarily on modular instrumentation, including CDAC, CRIO, and PXI systems, tailored to the specific requirements of each project. With LabVIEW, we can easily communicate with the PLCs, power loads, and EIS, electrochemical impedance spectroscopy equipment. To bring coherence to all these elements, we have developed our own platform, GEMS, which will become open source in 4 months. So this platform ties everything together, providing clients with a standardized, configurable testing solution that supports efficiency and scalability. And I believe, Samuel, you want to take over from here?
Exactly. Thanks a lot. It's okay. Do you see my screen?
I can see your screen, yeah.
Perfect. Just to talk about GEMS and the platform we try to create. I just want to give a background about what NI did in the last 5 decades, and they just give us the perfect platform to build what we want to build at Gemesis. First of all, NI is quite famous to create the first GPIB cards, but also the graphical programming language called LabVIEW and the graphical programming language. They also create a very efficient platform based on a computer with PXI and serial system, and give us the ability to do some FPGA programming or real-time programming. There are also some software connecting systems like TestStand, Veristand, Instrument Studio, and FlexLogger, who give us some flexibility and good tools also to develop a specific test bench. And regarding the data analytics, System Links is a very good, and IDEM for sure, is very good tools to get centralize the data and do very custom analytics data. I will present every software we use and every tools we use in the future slide, but just want to say that With NI, we have a very connecting system who give the ability to be optimized on the time to market, to reuse the data we are using, but also reuse the software we are creating, and this is very important for us. We have a connecting workflow. So since the beginning, when you start to develop technology to the production, you have very good tools to develop your systems. For us, we use mainly LabVIEW, very test on, but also system links and diagrams. Regarding that, we developed our own technology, GEMS, and I will present this software to you and to give you the idea of where we can use where we can use GEMS on some test bench and the development of the technology. Just before to talk about us, I just want to re-explain some tools that I developed in the past and still mainly invest on these tools. The first one is, I think, a very famous tools when you are doing test benches. It's called LabVIEW, and LabVIEW is a graphical programming language. So it's give the possibility to the user to create professional user interface, but also you can connect very different kind of instruments or PLC. For us, for example, it's give the ability to, when we use the NI platform, to be very fast and efficient. But it's give also the ability to work with other kind of platform like PLC from different hardware, different company, different kind of loads, different kind of sensor and feedback safety PLC. So it's very important to have this kind of tools. The community is huge also, and we strongly have a support. We have a support with this community. It's very important. And something also very important for us is the ability to code Python, C++, MATLAB, or .NET. So we can also exchange algorithm or exchange some code between this kind of software. Also, our customers are using sometimes this kind of software, so it's very important for us. GEMS is built with LabVIEW, so we use LabVIEW to develop GEMS. And the idea of GEMS is to give an open source platforms, mainly to develop hydrogen components, battery also test software. The platform gives the ability to the user to redeploy and redraw some diagram, or what we call PID, piping and instrumentation diagram. So you can edit it directly on the runtime. So you don't have to record everything. So you just have to load the pictures and to pick and place the sensor or the valve you want to control. It's also give the ability to the user to quickly configure the system. So you can create alarm procedure that you want to load with when you have this alarm detection. You have data logging, fault inspection, and we have also buses communication that you can do some parameters and configure a screen for that. We're also working on the model integration. So the idea is to give the user to load the model from different kind of language. It's also could be done on LabVIEW. For example, for a PID regulation, or if you have a more complex regulation, you can load the model and connect to the channel you described on the systems. It's open. So the idea of the business model is to open the source code. It's built with two things. You have the engine and you have the user interface. You can use only the engine or only the user interface if you want. But the connection between both, it's gRPC communication. So it's also an open source way to connect. And you can imagine to have, for example, a web interface if you want. We also have our own sequencer based on Excel sheets, so you can create your own description of the sequence. But if you want, you can also connect test on from a complex sequence. So I will give you just a show. I have just a video here, so I can give you the idea of what we are able to do. Okay. So here it's the place where you can just have a view of the diagram. So you can just load the backplane and select the pipe and drawing you want. But before that, you have to create your own channel. So this is what you see in this screen. You can create the channel, you can create the number, do the formula for the scaling of the data. You can create alarm, as you can see here, and you can have procedure regarding these alarms. Regarding the diagram, you can rename it. You can also use as a floating screen. And you can also save different kind of diagram. And you can have 2, 3, 4, 5 diagrams. So it's make the possibility, you have the possibility to create your own description of a subsystem, for example. Regarding fuel cell, if you have a complex humidifier, you can have a specific diagram where you have just a boxes called humidifier, and you can have a second diagram who explain everything's inside. You have the ability to also control the user, so you can log a user and select some rights that you can do. And here what we see is to the fact that we add a new indicator on the diagram, and it could be also a valve, and you can just configure it, change the label, and replace it. Just accelerate. For sure. So you have also the possibility to add a graph to see the data and to have floating data, to have a floating screen. So if you have 2 or 3 screens, you can create also your own environments to control the test benches. You can select 2 or 3 channels. Okay. I just accelerate the video. I will not explain all the features, only the main one. So for example, here we have Excel sheet who can describe Excel file who can describe a fuel testing condition to do the automatization of the test benches. So we will, if you're interested, you can contact us and we can explain you deeply how it works. And here you have the model screen where you can load model and select the input data of the model and the output data. And to finish, just here it's the screen where you can select a data file logging. So you can select you can pre-select some channels you want to log and to explain when you want to trigger the log session. Okay, let's go back to the presentation. So Gemesis is a perfect fit for some test bench, but for other kind of test bench, we also use Veristand. Veristand is a perfect fit for hardware in the loop systems because you can also load models for inside a real-time system like Serio or PXI system. You also can create model integration. You can describe your own system with the channel like Gemesis, but you have this real-time application that make Veristand very specific, and it's very well integrated with MATLAB, so you can also follow and debug your MATLAB code and Simulink code. So we use it with some customers on fuel cell to develop the FCCU, fuel cell control units, and to be able to develop to validate the code what they do inside. Testand also is quite very famous in the test specific area. We use it on a production test bench when you have very complex sequence, because Testand can call a very large kind of software and language. You can also create very specific sequence, and you can do the automatization of the report generation, the way that you send the data also to the database and so on. So it's a very good tool for that. And system links, it's quite very important also. It's very important for us because we use it from gens, but also from custom software that we can develop for customers with LabVIEW, for example, and Testand. System links is is a tools that you can deploy on the server, and you can just save all the data inside, and then you can do the analytics of the data. You can also give the rights to a system engineer, and he can have a look of the data provided by the test bench. So, and he don't have to have anything set up in his computer because it's a web-based application. So he can just have a look on the graphical data view on a web page. He can also download the data. He can do like Python scripting and machine learning algorithm directly inside the server. So it's a very good tool when you have a lot of the test bench. So if we go back to what Andy explained on fuel cells, usually you start from monocellule test bench to production test bench. On a monocellule test bench, for example, the one you can see, it was in our factory. We do some retrofit of this test bench. So we use GEMS to control this test bench to do monocellule test bench or short stack test bench. Monocellule is just when you want to work on the cell and the electrochemical things of the cells. Short stack test bench, it's when you want to have like a little stack with 2 or 5 kilowatts. And then you can also use high power test bench when you try to scale up your fuel cell. You can use GEMS for that also, because this is all this test bench. We will work with the FC lab to do the retrofitting of this test bench with our solutions. We use also in the past Veristant to do hardware in the loops test bench to validate the control command of the test bench and of the FCCU. And for all this test bench, we can use system links to get the data and give the ability for the system engineer or system architect of the fuel cell to work and understand deeply what you have inside. GEMS, Verisons, I love you also is a very good tool for loop test bench. For example, when you do just the thermical things on the thermical work on the fuel cell, but also you can also work only on the cathode or only on the anode. So you want to just use this loop and validate these loops. You can use GEMS for that. It's a perfect fit. If you also want to simulate a fuel cell in order to validate the calculator, the FCCU, for example, you can use Veristant for that. GEMS also if you want to have a rapid prototypings. And for sure, at the production, we can use GEMS with Teston to do our end-of-line testing systems and activation test bench. On fuel cell, activation is very important because you have to do the first start of the electrochemical reaction. And for that, it could be a very long time. So the cycle time on your test bench could be very critical. It could be some hours. So you need a lot of test bench to be able to produce your fuel cell. If you start to develop with GEMS, some very good sequences to do the optimization of the activation from the monocellule, you can use your same sequence on the end-of-line test bench. And for sure, we also connected everything on system links to get the data inside. So at Gemesis, we want to have a full approach. We use our open source platform, GEMS, from research and development to production. And this is something what you can reuse all the times to get the data in the same way, but also to work on it. And if you want to use it and to modify the source code, you have the ability to do it. But to give also a platform for engineers who want to work on fuel cells, we give the ability to, we have the ability to provide turnkey solution, but we want to give the ability to this engineer to also work inside our company, because we will open a test center in Lyon in France, to be able to work from the membrane to the fuel stack. And we will have something that's very new in the markets, who will give the ability to see what you have inside the fuel cell. But for that, wait 2 months, and we will give more information in the next months. We for sure we help engineer from also hardware in the loop to do very good and efficient control systems, and we go to advanced manufacturing solution, production line, and end of line test bench on battery and fuel cell electrolyzer technology. Just to finish that, I just want to finish on some very good story we have with customers. You can see on the left the first time where a company did a cryogenic tank, and this tank was able to to load hydrogen to a full distribution system for airplane. This company is called Universal Hydrogen, and we work with them on the fuel cell validation, not fuel cell, hardware in the loop. Sorry, hardware in the loop of the tank control command module. On the right, you can see here, you can see the monocellule test bench and short stack test bench from the FC Lab. FC Lab is a very famous research and development center in France, and we work with them to standardize the platform that they have. And on the back, we have an agreement with a company called Boreal. It's a partnership to give the ability to put hydrogen inside drone. And the idea is to test in a real condition some hydrogen components. So thanks a lot for listening to us. We have time now to give some chat response. So don't hesitate to ask what you have, the question you have, and don't hesitate to contact us also. I will put on the presentation my email, so don't hesitate to contact us if you have any question or any subject that you want to exchange. I wanted also to thank NI to give us the opportunity to present the company today, and also to do the quiet project that they are doing. Thanks a lot.